Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Wemet. And without any further ado, let's look at this question that we have here. Okay, so we have question 8. It says a crate of mass 8 kg was resting at point A on an inclined rough surface that makes an angle of 30 degrees with the horizontal. Two forces, F1 and F2, of 20 Newton and 100 Newtons. So that means in that order. So F1 is 20 Newton and F2 is 100 Newtons. And they say were simultaneously applied on the crate and it moved through a displacement of 20 meters, as shown in the diagram below. Right. Now 8.1.1. That's your definition. It says state the work energy theorem. Now we know we say work energy theorem states that the net work done on an object is equal to the change in kinetic energy of the object. In kinetic energy of the object. Right. That's how you define your work energy theorem for 2 marks. Then, okay, we have 8.1.2. It says, if the frictional force experienced by the crate is 8.5 newtons, note, calculate the net work done in moving the crate to point B. Now, what are they talking about? The net work done is a sum of all the work done by the forces acting on this 8 kg block, right? So note that is the sum, the total sum of all the work done on this object, right? So the first thing that we have to note here, we have to see all the forces that are doing work on this object, or all these forces that are acting on the 8 kg block. So the best way to do that is to draw a free body diagram. So note that even if they did not ask you to draw a free body diagram, for the sake of you having to be able to calculate successfully, then you need to be able to see all the forces that are playing a part there. So we have our FG parallel, and then still in that direction, remember, we have this 20 Newton force here, which we were told that it is force F1. So F1 like that. But then again, still in that direction, remember, we have a force that opposes the motion of the object. Now, we are told that this 8 kg block here is being pulled up the incline, meaning that there is a greater pulling force from the 100 Newton force here. So this 100 Newton force is opposing or is overpowering all these forces that are acting down the slope. So making your object to move up the incline, right? So even though it is just one force, but then it is able to overpower all these other forces that are acting down the slope. So causing the work done to be in the positive direction there. So, okay. We have our F2 here like that. Now that we've shown all the forces that are acting on the object, we can be able to spot the ones that are doing work. Now we know that perpendicular forces to the displacement do not do any work. So your Fn, normal force, and your Fg perpendicular, they will be doing no work, right? Why is it so? Because their theta is 90 degrees. They are perpendicular to the displacement. So forces that are perpendicular to the displacement do not do any work, right? So that means the only forces that are doing work is the Fk, F1, Fg parallel, and F2. But then also there's something that you need to note. Theta will be 0 degrees if the force is in the same direction, as the displacement, right? Or the direction of motion. And then theta will be 180 degrees if force is in opposite direction. To the displacement, right? So that means all the forces here, they're in the negative direction of motion. Why? Because the 8 kg block is moving up the incline. So they said it there. were simultaneously applied on the crate and it moved through a displacement of 20 meters. If it moved through a displacement of 20 meters, that means it moved from point A to point B, meaning it was moving up the incline. So up the incline becomes the positive direction and down the incline becomes the negative direction. But the one with the positive direction will have a theta of 0 degrees. It's in the same direction as the displacement. The one in the negative direction will have theta of 180 degrees because it's opposing the displacement. So that's what you want to analyze before you can start solving the questions. Right. So now if we are to solve the W net, we know that it will be a representation of all the forces that are doing work on this object here, the 8 kg crate. So W net will be composed of the work done by F1 plus the work done by FG parallel plus the work done by FK, and then also plus the work done by F2. Note that I'm not subtracting the forces. When it comes to W net, you do not put any subtraction sign there, because what will bring about the negative sign is you having to put your theta as 180 degrees. Now remember, from this formula, W is equals to F delta X cos theta. We know that cos 0 degrees is a positive, but cos 180 degrees is a negative. So what really tells us if the force is moving in the opposite direction is you having to substitute by 180 degrees, not showing that it's a negative work done. Right. So we have our W net, and then let's write all these forces here. So let me, because it's going to be a long one, let me just write it from here. So work done by F1, that will be F1 delta X cos theta plus work done by FG parallel. We know that FG parallel breaks down to mg sine theta and then delta X cos theta, right? Then work done by FK, that's your FK delta X and then cos theta. And then work done by F2, that's your F2 delta X cos theta, right? So all these forces will be representing our W net. Now let's substitute. We do have the values. So we have our F1. Remember, we were told F1 is 20 newtons. So that's 20. And then our displacement, 20. Remember, they said it moves through a displacement of 20 meters, and it's even shown here. Then cos, remember the F1 is acting in the negative direction, so that means theta is 1/8. Then we have our mass here, 8 times 9.8 sine. Now there's a difference between this theta here and that theta. The theta from mg sine theta is the theta of the angle, but the theta from here speaks of the angle between the displacement and that particular force. So for this theta here, I'm going to substitute 30, and then I have my displacement as 20. But then because FG parallel is also acting in the opposite direction, then the theta in here must be 180 degrees. So always note that. Then my FK, I was told that it is 8.5. My displacement, 20. And then cos 180 degrees. So you can now see all these forces, 3 forces that are acting down the slope have an angle of 180 degrees because they are opposing the displacement. So note. I'm repeating that over and over again so that you understand. Then F2, we have 100. Delta X is 20. And then cos, note for this one, now that's where I'm going to have my angle is 0 degrees because it's acting in the direction of the displacement. Now, when I punch all that into my calculator, that means my W net. So if I just punch this 20 cos 180, that's negative 400. If I punch the 8 times 9.8 sine 30, 20 cos 180, I'm getting a value of negative 784. And then if I punch 8.5 times 20 cos 180, I'm getting a value of negative 170. And then if I punch the 100 times 20 cos 0, then I'm getting a value of positive 200, right? 2,000 meant to say 2,000, then W net is equals to all of this into your calculator now. You get 646 joules, right? So that becomes your W net. So that's the net work done. Okay, so you can say that there was nothing challenging to it, just a matter of having to illustrate everything into your free body diagram and then having to know how you substitute in the angles, your 0 and 180 degrees. But other than that, it was a straightforward question. Now, let's look at 8.1.3. Using energy principles, use energy principles to calculate the velocity of the box as it passes point B, right? Now, if they say use energy principles, we know that we have an option of using W net is equals to change in EK, or we use WNC is equals to change in EP plus change in EK, or we use sum of mechanical energy at A is equals to sum of mechanical energy at B. Now remember, I did mention the conditions for all these three, right? Now for this one, we're not going to be using this one because this one only works when there is no friction. So this one has to be only works in isolated systems, right? Only works in isolated systems. So it has no chance of being used here. And then now we are only left with W net and change in EK. But then with WNC, the WNC work done by non-conservative forces, we know that this one we would have to know the height, right? So most of the time we prefer this one if either we want to calculate the height or we are given the height. Now looking at this, we can see that we do not have the height anywhere. So that leaves us with W net. So the W net will be the one that we're going to use effortlessly, because all we need to do here is say 8.1.3 W net is equals to change in EK, right? Then we have W net. W net, remember, we have the value for W net. So let's start by breaking down this. Vf squared minus Vi squared. Now remember from the previous question, what were we calculating? The net work done. The net work done is the W net. So 646, right? And then here we have half. Our mass is 8. V finally, that's what we are looking for. The velocity as it passes point B. So we are looking for the velocity at that point B, right? So that's Vf squared. But V initially, when we read here, they said a crate of mass 8 kg was resting at point A. Resting. So that means the velocity at point A was what? 0. That's your initial velocity. 0 square. Now from here, 646. What's half of 8? That's 4. 4 multiplied by Vf squared. That's Vf squared. This point, we just divide both sides by 4. Now my Vf squared is equals to, so I'm going to punch this into my calculator. I have a 646 divided by 4, which is giving me 161.5. And then if I have to square both sides, then my final velocity rounded off to 2 decimal places becomes 12.71 meters per second. Right. So as straightforward as that. It's just a matter of knowing what are your energy principles and having to select the one that will enable you to calculate what you are being asked there. Okay, so now let's move. We have 8.2, a race car with a mass of 1,500 kg can reach a speed of 26 meters per second from 0 meters per second in 4 seconds. Calculate the average power. Calculate what? Average power output of the car's engine. Now, before we calculate that, let me first start by giving you what is the definition of power. So we say power is the rate at which work is done, the rate at which work is done, or energy is dissipated or transferred. So the word dissipated means transferred, right? So this is the rate at which work is done or energy is dissipated. From this, I can deduce that my formulas for power can either be W over delta T, or can be W is equals to change in energy, so EK over delta T. So that means either one of these formulas can be used to calculate the power. So it's either I have the work done, or I have the change in energy, right? Change in kinetic energy over delta time. Now it's a matter of deciding from the information that I'm given here, is it simple to calculate the work done, or is it simple to calculate the delta K? Now check this. I have the mass, I have the final velocity, and I have the initial velocity. Remember, this is final velocity because they said it reaches a speed of 26 meters from 0 meters per second. So that means it starts from 0 and then it reaches to 26, making 0 the initial and 26 the final. Now from all this, I have M, VF, and VI. Looking at the formula for changing EK, I can see that this fits perfectly to that. But then if I were to check the formula for work, that's just F delta X cos theta. I don't have anything to calculate my work here because I would need to have the force applied, I would need to have the displacement, and then I would need to have the angle there, right? So I don't have any of those. Remember, when choosing the formula, you choose it based on the data that you have. The formula must correspond to the data that you are given. Now, from the data that I'm given, I can see that I can quite calculate the change in EK effortlessly so. Then that means change in EK is equals to half M VF squared minus VI squared. Now that's my half. Mass is 1,500. So I'm not concerned about anything. It's just plug and play. Just simply putting what I'm given into the formula. And then if I punch that into my calculator, I get a value of 507,000 joules. Right, remember it's energy. Then, now to calculate my power, change in EK over delta T, which now I will have 507,000. And then did they give me the time? When I read here, they said in 4 seconds, right? So moves from 0 to 26 meters per second in 4 seconds. And that's where I have my delta T. So that means my power is equals to 507,000 divided by 4 into my calculator. I have 126,750 watts. So remember the SI unit for power, so watts. And then just like that, I've calculated the average power output of the car's engine, right? So always put that into your mind in terms of how you choose the correct formula to use, especially in topics like this, whereby there are multiple formulas to choose from. You need to be very creative in the way you select the correct formula to use. Okay, so with all that being said, guys, please press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.